Hi, I'm Philip Bille. Welcome to this video on the union find problem. First, let's define the problem. So the union find problem is to maintain a dynamic family of sets under the following operations. The init operation takes a parameter n and constructs n singleton sets. So for instance, if I do init 9, then I get these 9 sets that we see here. The union operation takes two elements I and j and forms the union of the two sets that contain elements I and j. So for instance, if I take union 5.0, then I take the set, in this example here, we have 3 sets. I take the set containing the 5 element and the set containing the 0 element, and then I take the union of those to get this new set here. If we do union on 2 elements in the same set, so for instance, if I do union on 3 and 2, then nothing happens. Finally, the find operation returns a representative for the set that contains I. The representative can be any element in the set, and it's up to the data structure designer to define what the representative should be. The key property is that if you take find on 2 elements from the same set, they should return the same representative. In our example here, we've marked the representative with red, so the representative of this set here is this 1, the representative of this set is 3, and the representative of this set is 5. So for instance, if I do find 7, then I should return 3. The union find problem is a very basic problem that appears in a number of interesting applications, and we'll see some of these applications later on in the course and in future courses. So let's see our first data structure for the union find problem. We call this data structure quick find. The quick find data structure consists of an array ID of n elements. The ith entry stores the representative for I. So for instance, if we look at this configuration down here of 3 sets, we have that the first set has representative 1, and we mark that then in the ID array by saying that, well, element 1 has representative 1, element 0 has representative 1, and element 6 has representative 1. Similarly, this set here, the representative is 3, so 8 should have representative 3, 2 has representative 3, and so on. So we implement the operations as follows. First, if we do an init, then what we do is we simply make an array of size n, and we set each element to be its own representative. So this is the configuration after an init 9. To implement union, we first check if the input elements are from the same set by checking if they have the same representative, which we can just look up in the ID array. And if they are not from the same set, we update the representative for all elements in one of the sets. So for instance, when we do this union 5.0, we are in the case that these two are from different sets, right? So this is the set containing 1, and this is the set containing 5, set containing 0, and the set containing 5. So when we do a union, we update the representative for all of the elements in one of these sets. In this case, we update the representative for all of the elements in this set. So that corresponds to saying that, well, the representative over here on the right hand side of element 4 should be 1, and element 5 should also be 1, because that is the representative of this other set that we're unioning with. What we end up with is this set here represented, so all of the elements here 0, 1, 4, 5, and 6 now have representative 1. Finally, to implement find, we simply return the representative. So quick find is straightforward to implement, and here is the full pseudocode. You spend some time thinking about why this implements the operations we just described. We immediately have that the init operation takes linear time, the union operation also takes linear time, and find takes constant time.